Welcome to AI Podcasts. I'm Ethan, and with me is my co-host, Maya. Today, we're talking about a new EMNLP findings paper called Self-Guided Function Calling in Large Language Models via Stepwise Experience Recall.
Catchy acronym to SEER. What's the quick headline here, Ethan?
The gist is this. When an AI agent needs to call tools over several steps, SEER helps it choose the next tool by recalling just the right bite-sized examples from its past successes, step by step, and it keeps learning from new wins as it goes.
So instead of stuffing a prompt with a few generic demos and hoping for the best, it pulls up examples that match the situation it's in right now. Who's behind this?
Led by Sijia with colleagues at the Chinese Academy of Sciences, the work appears in Findings of EMNLP 2025.
Great, let's set the stage. What problem are they trying to fix?
Multi-step tool use is messy. An agent has to pick the right tool, craft the arguments, then plan a chain of calls. Prior systems often lean on hand-picked demonstrations or retrieve a couple of canned examples by matching the original query. That breaks down when tasks branch, user goals shift midway, or the tool list is long.
Right, because the example you needed at the start might not help 3 steps later. So how does SEER think about this differently?
Think of the agent as a traveler with a scrapbook of past trips. At each intersection, SEER says, don't scan the whole scrapbook. Pull a few pages that look like the detour you're facing right now. It scores past trajectories using 3 simple signals: how similar the current conversation is overall, whether the same tools are showing up in the chain so far, and whether the user's intent matches.
Like checking the route, the landmarks, and the destination, and it only grabs a small handful, not the whole scrapbook.
Exactly. Then once the task is finished, if the answer checks out, the agent files that new trip into the scrapbook. So the memory grows with experience instead of staying frozen.
Wait, if the answer checks out, who decides that?
An LLM is a judge. When the task has a clear reference or verifiable outcome, the judge confirms success. For fuzzier tasks, they still use the judge but acknowledge it isn't perfect.
Got it. What did they compare against?
A spread of well-known agent baselines, things like React for reasoning plus acting, and methods that retrieve multi-step traces from a static library. SEER bolts onto the same backbone model and uses deterministic decoding to make comparisons clean.
Deterministic meaning temperature set to 0, so we're not riding randomness. Nice. What about the datasets?
2 families. First, Tool QA, which is a single-turn but multi-step tool use benchmark across domains like flights, Yelp, academic data, and reasoning. Second, Tau Bench, which is multi-turn and more realistic, airline and retail tasks with policy rules and a user simulator. In TAU Bench, they even use GPT-4 to play the user.
And the results, without drowning us in numbers?
On Tool QA, SEER improves accuracy by roughly 6 points on easier sets and about 5 on harder ones over the strongest baseline. On Tau Bench, the smaller open model jumps from roughly 9% success to around 17%, and the larger one climbs to just over 50%, close to GPT-4 on that benchmark, but still shy of a top open alternative like DeepSeek.
So the practical read is, if you're running a smaller or mid-sized model, SEER gives you a free lift just by managing examples smarter.
That's the feel. And they show self-improvement over time. As the experience pool grows across batches, performance trends upward like a slope from early, modest accuracy to noticeably stronger later on.
Nice. Any ablations or insights on why it works?
Yep, each of the 3 signals matters. Dropping toolchain overlap hurts the complex, multi-tool cases the most. Dropping the intent match mainly hurts the simpler ones, where you can overthink. Also, using too many examples backfires. More pages from the scrapbook can actually distract the agent. A small, well-chosen set tends to be best.
That tracks with intuition. I'm curious about pitfalls. Where can this go wrong?
A few things. First, depending on an LLM as judge can introduce bias or edge case errors. Second, the scoring weights are fixed across tasks, so what's optimal for airline refunds might not be optimal for academic lookup. Third, the quality of the growing memory is tied to the base model. If the model rarely succeeds on a corner case, the pool won't collect good examples for it. And on one tool QA subset, coffee tasks, the stepwise retrieval sometimes made simple problems look more complicated, though a light reflection step helped.
So it's not magic. It's a system that needs sensible guardrails. What about reproducibility and setup?
They kept decoding deterministic, described the tool limits and steps, and provided clear tables. That said, results are shown as single runs without confidence intervals, so I'd still want to see variance across seeds in future work.
If you were to apply this tomorrow, what's the mental model?
Picture an agent that, at each turn, asks three quick questions. Does this look like a past conversation? Am I using a similar set of tools? And is the user trying to do the same kind of thing? It pulls a few relevant mini-stories and uses them to decide the next call. If it solves the task, that mini-story gets filed for later. Rinse and repeat.
And where does this go next?
Adaptive retrieval that learns how to weigh those signals per domain, stronger verifiers that combine rule checks with LLM judgment, and smarter memory management so the pool stays diverse instead of bloated. I'd also like to see experience sharing across models. Say a big model curates examples that a small model can actually use.
Sounds like a clear path to more reliable agents without retraining them. Let's wrap with a takeaway.
Sure, SEER shows that tool use isn't just about bigger models or longer prompts. It's about remembering the right experiences at the right moment, one step at a time, and letting that memory grow with use.
Exactly. If your agent struggles with multi-step workflows, try teaching it to recall like a seasoned operator, not cram like a student the night before. That's the heart of SEER.
This has been AI Podcast. Thanks for listening, and we'll see you next time.